Okay, hello everybody. Welcome to the NASA Earthdata webinar, Geospatial Data Abstraction Library, or GDAL Enhancements for GIS. This is your host, Jennifer Brennan. While everybody's logging in here, and I see that most of you have already noticed this, but we do appreciate your feedback on the two optional polls at the bottom and middle portion of the page. So we've got 2 p.m. Eastern Time, and we're going to go ahead and get started. So first, I'd like to begin by going over a few housekeeping items related to this webinar. To ensure the best audio experience, the conference has been placed in silent mode. So if you have any issues or you have any questions, I'd like for you to enter those into the Q&A pod, and you can see that in the lower right-hand corner of your screen. And this works just like a chat. The webinar will be recorded and posted to both our NASA Online Adobe Connect event catalog and also to our NASA Earthdata YouTube channel within a few days of completion. These URLs will be provided to you at the end. All presentation files will also be available for download at the end of the webinar. As far as timing is concerned, this webinar is 1 hour long. 45 minutes are allocated to the presentation and demonstration, with another 15 minutes for the Q&A period. After the speakers have finished their presentations, we will then move to a final set of polling questions. So as I mentioned earlier, you will have an opportunity to ask your questions throughout by using the Q&A pod. However, questions will not be answered using the raising hand function. It has been disabled. What we'll do is we'll take all of the questions using the Q&A pod at the end. So what I'd like to do next is move to our agenda and also a speaker introduction. Our first speaker today is Brian Tisdale, who is a systems engineer at the NASA Langley Atmospheric Science Data Center Distributed Active Archive Center, or ASDC DAAC. He will provide an introduction to the project and also an overview for the existing framework with a specific focus on how to extend GDAL to support plugins. He will then complete his portion of the presentation with information about upcoming deliverables and next steps. I'm going to scroll down a little bit here so you can see the remainder of the agenda. After that, we will transition to our second speaker today, Matthew Tisdale, who is the team lead for the Advanced Architecture and Engineering team at the ASDC DAAC. He will provide demonstrations on how to write XML files to leverage required plugins and use XML files in GDAL command line tools and ArcGIS Desktop. It is my pleasure to introduce our first speaker today, Brian Tisdale. Brian?
Thanks, Jennifer. So this afternoon I'll be providing an overview of the Geospatial Data Abstraction Library enhancements for ESDIS, and throughout this presentation I'll refer to this project as G. Thanks to funding from ESDIS in support of the Big Data Earth initiative. So this project was kicked off due to a problem that we were seeing at ASDC and across other data centers, and hearing feedback from our user community that the NASA Earthdata products are often frequently unable to be opened or properly interpreted in geospatial applications when trying to do visualization and analysis. And on the right you see two examples of that. So the top one being a product that we have here available at the ASDC, our Moppet 03TM HDF4 product. And if you'd open that in most geospatial software today, you would notice that the image is inverted. In this case, we overlaid the countries just to show that a little bit more clearly. Additionally, underneath that, you'll see the same product, but the HDF5 version we make available. And just due to the structure, the difference in the structures between HDF4 and HDF5, you get different behavior. So that same data product, but in HDF5 format, if you open it up in a GIS software, would not have any georeferencing information, and it would be 90 degrees rotated. So our goal for this project is to look to see whether or not we could create an extensible GDAL augmentation framework that allowed us to correct these types of issues without having to reprocess all of our data sets, so that those using these GIS software, the data sets would properly be interpreted. So we started looking across all of the geospatial software that we use, and we noticed that the common denominator to all of them is the GDAL library. And this is the library that most applications use to create that raster data model. So digging a little deeper, we felt that if we could make the correction within the GDAL library, this would be extensible across most geospatial software and not just a specific solution. I'd also like to thank our partners on this effort. So several individuals at the ASDC, our colleagues at George Mason University, the HDF group, and Esri. So how do you determine if you have a need for G? Are you seeing issues in your data sets? This is really based on the fundamental issue that there's no universal way of storing georeferencing information in HDF files. You will notice if you open up different HDF or HDF products that some of them might be following the CF or the CORDS conventions, but the GDAL driver doesn't currently utilize that information. Additionally, things like VData in HDF4 and Compound in HDF5 are not even readable by the GDAL HDF driver. So these are areas where many NASA products store georeferencing information, but GDAL cannot access that information. However, over the years, there have been mechanisms added to the products for storing georeferencing. And additionally, the GDAL library has adopted specific code fixes for given products. So you see a list here of data sets that work today with no issue. So if you're leveraging one of these products in an HG or in a GIS application, you're likely not going to have some of the challenges that we're talking about today, and that's because a custom fix has already been written into GDAL over the years. In addition, if your data set does follow the HDF EOS standard and it's leveraging the GCTP package for storing georeferencing information, those products will likely work as well, and that is because GDAL has added a way to read HDF EOS georeferencing information. However, many of the products that we provide do not follow that standard. So based on that, we have come to the conclusion that the GDAL HDF driver is just a little too rigid currently, and there's just no way it can support all conventions that we're seeing across the HDF products. So that's why we had the goal here to look at some way of creating this XML control file that allows you to identify that referencing information without reprocessing all of your data. So here's some general guidelines that we follow when we're looking at a data set. So oftentimes if we're presented with a new data set and we're trying to determine whether or not our users are going to have any challenges using that in the GIS application, these are the general steps we follow. So we always encourage our users to go out to the GDAL HDF4 and HDF5 website and look to see whether that data product is already supported. The list I showed previously is compiled from these websites. So like I said, if you see it on there, you're probably not going to have any challenges. Additionally, we encourage the community to leverage the HDF Group Zoo website. So on that site, they provide a comprehensive list of examples on how to access and visualize NASA products from many DAACs and many different software applications. So that's another great resource to see whether or not the HDF group has already identified whether or not you're going to have challenge with those data sets. And they've likely shown examples on how you can correct them in different applications, not just geospatial, but just other software that uses the GDAL library. After that, we recommend that you leverage the HDF View software from the HDF group to confirm that the file is not corrupt. So, the most basic step is to make sure that the file does open up in HDF View. So, and then you can check to start to understand what the array structure is. And then if you run the GDAL info tool, that will tell you what information GDAL is able to read. So I mentioned the VDAL and compound challenges. So if you notice that when you're looking within HDF View that all your georeference information is stored in VData, and then you run GDAL info and you don't see any georeferencing information, that lets you know that there's going to be some challenges with using that data set. And then you can run the GDAL Translate to try to export that out to a GeoTIFF. We recommend this for multiple reasons. It allows you to know that the issue doesn't have to do with the HDF file itself, so let's eliminate some of the possible issues. So we recommend exporting it to a GeoTIFF. And if it completes exporting as a GeoTIFF, that doesn't necessarily mean that you're not going to have any issues. That could mean that it did create an image, but you'll still have to make sure that it's not inverted or rotated. So with that, we then encourage you to leverage visualization applications to analyze that GeoTIFF. GeoTIFFs are supported by most GIS applications, more so than HDF and NetCDF, so that's another reason why we always recommend GeoTIFF for that initial testing. And then you can compare your results also with the plots that are made available by the HDF group and the zoo. So the middle image you see there is an example of a Python plot that the HDF group does provide. So you can compare what you're seeing in that plot to what you're seeing with your GeoTIFF. So another example down here on the bottom right is if you were to go and export one of our MOP03T products using the GDAL Translate today to a GeoTIFF and open it into something like Google Earth, you would notice that the image doesn't have any georeferencing information, and it doesn't look anything like what the example the HDF group has provided. So if you're seeing these types of challenges, you're most likely going to need something like G in order to address the issues. So we started to look at how to build out this framework, what we could leverage that's already available. So we took a real close look at the GDAL virtual format. So this is a augmentation framework that is already available for GDAL that allows you to write this control file to make modifications to your metadata and associate coordinate system information. So, it's along the same lines as what we wanted to accomplish with this. However, when we started looking at it, there were certain capabilities that it just did not support for the types of issues that we currently had, which we'll talk a little bit more about in the following slides. Additionally, if you use the NetCDF Java library, it also supports a similar type of concept that they refer to as NCML. So things like OpenDAP, you can correct these control files for those applications as well to make these alterations. So we came up with our generic framework on how we were going to approach this. So starting at the bottom, the idea is that we have several products hosted here at the ASDC and across other data centers in HDF4 and HDF5 formats. The GDAL library actually has embedded in it the HDF4 and HDF5 library, which has the HDF4 and HDF5 drivers. So we really wanted to focus on how we could modify those drivers to properly interpret our data sets. So we found the need that we had to add 4 additional functions. And then the concept would be is that this XML file can leverage any of those 4 functions. And then that's what we save those, and that's what we consider these plugins that the applications can then leverage. So what were those changes that we had to make inside of the HDF4 and HDF5 driver? Here are just some quick examples of that. As I mentioned previously with the VRT, it primarily focuses on the image data set function that's in GDAL now within the HDF4 and HDF5 drivers. However, some of the issues that we had could not be fixed just within the image data set functions. We had to take advantage of the raster band function as well, so that's specifically for our issues with inverting and rotating images. So we've added functions to the raster band class that can now be leveraged within our XML files. So we had to add some new functions to also be able to open that XML, and then additionally we've revised some of the functions that are also in those drivers. So what are those 4 functions? Here's just a quick overview of the 4 that we've initially developed, and this was based on issues that we've seen across the ASDC. We've also had some input from some of our DAAC partners that are seeing similar issues. Things like metadata, where it's simply there might be a no data value, but the tag that they use might be different. So that, we now have a way of just denoting what the no data field is in the data set. If the image is rotated or flipped, there's the function, and you can see an example image of how we approach the inversion of that. A very popular issue is the need to access our 3D, 4D, 5D, or multidimensional sub-data sets within these arrays. So as an example I'll show shortly is one of our data sets by default, the array is structured 180 by 9 by 360. So now we have a way for the user to say which subset data set they actually want to visualize. And in this case, it's 180 by 360 with 9 height levels. And we've added functionality for ground control points. So the way we're leveraging these functions is through the idea of a plugin, which is that XML file that I referred to. So we have developed a very basic schema. I will note that this schema is under significant revision. We came up with an initial proof of concept, and now we're looking much closer at the VRT framework and the other challenges to make sure that our schema is extensible enough to address all issues and not specific to our products. But this is just an example of how that schema is currently structured, with the idea that you create this very basic XML. You see the example here where you identify what the product is, what the format is. The format is very important currently because the challenges are different with HDF4 and HDF5 products. Define what the problem is. This is just general commenting so that a user can understand what issues they're expecting. And then you note what functions you need to apply to that data set. So for our Moppet example, it is inverted upside down, it is missing the no data value, and some of the arrays are multidimensional. So you'll save that XML into a directory next to the corresponding HDF file that you want to leverage. We are also developing a plugin repository. So as we develop these XMLs for files here at the ASDC, we are going to make those available to our user base. So although you can write your own and leverage the functions for products you're working on, there will also be a resource to see if one has already been developed for known issues. So that's just a snapshot of what we're attempting to do. And I will also note that this is also where we're working closely with our science teams for verification of this as well. So we at the ASDC will not make an XML available on this repository until we've coordinated with our science team partners and confirm that we have corrected the issue without altering the scientific integrity of the data set. And we plan for this list to continue to grow as we continue our outreach with our other DAAC partners. So what are the results of this effort? Some quick snapshots here just to show you that we were able to successfully correct many of our issues thanks to the G effort. So the first being that image inverted on the right, you'll now see that it is rendered correctly. The one that was rotated and missing georeference information, that now is also able to draw properly. And then a test example where I mentioned that previously the 3D subset thought the array was 180 by 9, so you would get this black strip of data, whereas now you can identify which dimensionality you want to use for a given sub-data set, and now you properly can visualize that. Additionally, I mentioned the no data flag, so we wouldn't consider this an error in the data set and the visualization because it would render correctly, and you could adjust your own scale. However, if the no data value is in the data set and we can quickly reference that in the metadata, we do think it's an added benefit to the user. It's one less thing that they have to adjust when visualizing the data set. So you'll see on the right, by default now, it ignores the no data and applies the appropriate color ramp to the data set. And there's two more examples where we've had challenges with the missing reference information in 3D data sets. So what is available to the community for information on this? We are putting together a thorough user guide on how to develop these XMLs, how to get the latest version of the repository, and how to test it in several applications to include the command line utilities and tools like ArcGIS, which Matt will provide a demo of. All of our outreach presentations are available to include the presentation today, and then the repository itself. So we've taken the 1.10 version of the GDAL repository and added our enhancements to the library. We've also ported that for 2.0. In addition, we've developed an ArcGIS extension, and this is primarily for our testing purposes so that we could quickly, within ArcGIS, confirm that our enhancements are working appropriately without altering the ArcGIS GDAL library that it's based on currently. So this creates an in-memory raster and currently supports ArcDesktop 10.2.2. Access to all the information will be available through the Earthdata Code Collaborative. Great resource that we've been able to leverage for the life cycle of this project, leveraging the wiki, bug tracking, and code repositories that are available in that tool. So if you do want access and you go out to the ECC page, if you search for the project GDAL Enhancements for ESDIS, you can then request access to all of these deliverables. All are available in draft form, and we just continue to refine them. Okay. So moving forward, our goal is to make all the guides, tutorials, and repositories available. They are available now if you want to reach out and get a draft. And we're looking for feedback from our partners and opportunities to collaborate to identify additional issues and continue to enhance the GDAL library as new issues are identified. We also intend to continue to enhance the framework to make it more extensible. We're looking at, as I mentioned, developing a more flexible schema, and our end goal is to integrate with the GDAL VRT. All the enhancements will also then be added to the public GDAL branch, so we are in discussions with the larger GDAL community to make sure that everything we're doing can be incorporated into the GDAL branch. Because our goal is that you don't necessarily have to go get our version, or you should be able to, if you're using any software that is using the latest and greatest version of GDAL, it will then support our functions. So we are additionally coordinating with other developers of ArcGIS, QGIS, etc., to make sure that they're going to be willing to adopt the latest version of the GDAL branch with our functions included once it is available. And we will continue to identify and document our plugin compliance certification. That's that process that we're working on here at the ASDC to make sure that our science teams are validating the functions that we're implementing and the recommended changes that we're proposing to the community, and continuing to maintain the repository that is available. And with that, I'll turn it over to Matt to provide a demo of these efforts.
Thanks, Brian. As part of this demo, we're going to discuss the need for G. We'll show how to use G in GDAL Translate, and then we'll look at the ArcGIS extension that we've built that makes it a little easier to work with the G application and software that's been developed. So we'll do an installation of the ArcGIS extension. We'll add the toolbar to ArcGIS for desktop. We'll then create an XML file and open the HDF file that's related to this XML with the fixes applied. And then we'll export the data to a GeoTIFF format. So first, when we were starting to look at this project, we were looking at data within ArcGIS for desktop. Here is a native file, a MOP03TM data product. And when we bring that into ArcGIS for desktop, at first glance, it looks like it's okay. It's displaying on the map. But if we look to the left, we can see that the low value is -9999, which is incorrect for this particular data set. Since this is temperature data, that value is way too low, and it's actually a no data value that's in the data set. So we can make some changes within ArcGIS for desktop to do some further analysis to look at this data product. So we'll go ahead and adjust that low value to be a correct value, and then apply a color ramp to this data. So we'll go ahead and do that. And we can see now that there's obviously an issue. We can look and see Africa and Australia in there, and they look inverted. So this is how the product would look without G loading it into ArcGIS for desktop. So this is really where the need was created to develop the G software to better implement within these GIS tools. And so here we'll go ahead and load on a base map too to just further show the issue with the data product within the ArcGIS application. So we can see that the continents aren't lining up, and this is a base map provided by ArcGIS for desktop that has the correct georeferencing. So we can see that the image is in fact inverted. And this is a raw HDF data product. So now we'll actually run that product using GDAL Translate, and we'll export out a GeoTIFF of that data product that we were just looking at. Here we have that GeoTIFF and pulled it into Google Earth. And you'll see that this has similar issues. This is the HDF data product, or HDF5 data product, and it's not able to georeference correctly on the globe. And so this is just showing that ArcGIS for desktop and GDAL, the native library, both are built using the GDAL library. and have similar issues. So if we can address these issues at the GDAL library level, then we can fix these data products in multiple applications, such as ArcGIS, Google Earth, and QGIS, just to name a few. So in order to start working with G and the GDAL Translate tool, we'll first download, compile, and install our repository from the Earthdata Code Collaborative. Once we've downloaded that and set up and installed and compiled it, we can run commands from the command line, and then we can also create the XML file. So you'll see in the gray box here a sample of one of those XML files with the functions applied to fix this HDF4 Moffett data product. So we'll call these 3 functions within the XML to fix those issues. Now that we have this XML, we'll save that, as you see in the middle right image there with the documents library, into the same location as our HDF file. And we'll just append a .xml to the end of that file. So what this will do is now when we load that data set, it's going to actually apply these functions to the data set and fix the issues in our applications. So in this case, we're going to run the third bullet here, the GDAL Translate command, and this will take our HDF file and generate a GeoTIFF out of this, applying those functions to fix the image. Once we do that, in the very bottom, you can see 3 applications now that have been used to load that data. So we can look at Python, Google Earth, and ArcGIS Explorer are now all correctly interpreting that data. So that was how to run it from the command line to create a GeoTIFF that you can then use in these applications. We've also developed an ArcGIS extension to make it easier for users to test our G enhancements within these tools. So there's an installer file on the Earthdata Code Collaborative that you can download. You'll see this setup.exe, so we'll just double-click that to run this install application. So we can click Next. Then we can define what folder we want to install this to and what users we want to give access to this tool. Now that we do that, it'll run the install. This will only take a couple seconds to install. It's a very quick install. And then we can hit Close, and this will finish the installation for that ArcGIS extension. Now that we have the extension installed, we want to launch ArcGIS for Desktop in ArcMap. So here we have ArcMap loaded. If we right-click on the toolbar area, we can then add a new toolbar. So we'll go down to the Customize. We're going to customize our toolbar. We'll select, after the installation, it'll automatically point to this directory here. This will be the TLB file that we'll have to select to associate the installation that we just did with the toolbar that we're adding in ArcGIS for Desktop. So we'll click Open on this, and then you can hit OK to add the objects. And now you'll have a new option in your toolbars column here. At the very bottom, you can see this HDF Data Access. We'll click the checkbox next to that, and you'll notice in the top left of ArcMap, there's a new toolbar appearing with a little folder icon. So that means we've correctly added the extension into ArcGIS for Desktop. So now that we've done that, we want to make our XML file that we need to sit alongside our HDF file to apply those fixes. So we'll create, similar that we've seen through these slides, another XML file and apply those different functions to that file and save this as XML within that same directory as our HDF file. So now that we have both of these files, we can go back to ArcMap and use our ArcGIS extension to pull these into ArcGIS for Desktop. So we'll double-click on the folder icon here within our toolbar, and it'll ask us to open a net HDF file. So we'll navigate to that particular HDF file. You'll notice that the XML isn't displayed, but it is using that in the background. So we can just point it to the HDF file that has that associated XML and click Open. And then it'll present us with all the sub-data sets within that file. Before, we wouldn't be able to see all these different sub-data sets. In this particular case, for trees, CO, mixing ratio is actually a 3-dimensional parameter. So these are different levels of the atmosphere, and it's displaying each one of these for us so that we can select those. So we'll just, out of this sub-data set, select the first 4 layers of the atmosphere that we want to visualize and hit OK. So it'll automatically pull these into ArcGIS for Desktop. If you wanted to select more parameters, you could do that as well, or all the parameters that are available within that data product. And it'll load those into ArcGIS for Desktop. So we can see now, if you look at the center, you can see Africa is clearly identifiable in the image, and our data is displaying correctly within ArcGIS for Desktop. So at this point, we could then start to do any kind of analysis that we want with the product within ArcGIS for Desktop. Right now, it's stored in memory as a raster data set within ArcGIS for Desktop. So if we want to use this in another application or in other tools, then we need to export this. So if we right-click on any of those layers within the table of contents on the left and go right-click and click Data and Export Data, we'll then be presented with another window where we can select what kind of raster format we want to export that to. So here we could change the format of the data, cell size, or any other configurations that we'd like to export, and then use this either in ArcGIS for Desktop or other tools to access this information. And this just makes it a lot easier to integrate directly with the tool and to do those G enhancements that we worked on directly in ArcGIS for Desktop without having to run directly from the command line. So if you'd like access to any of the deliverables that are available, either the code, the documentation, or the plugin that we just discussed with ArcGIS for Desktop, you can please contact myself, Brian, or Tiffany Matthews at the ASDC. And with that, I'll turn it back to Jennifer.
Okay, thank you, Matt. Thanks, everybody. What we're going to do next is we are going to move to a final set of polling questions. And I'll give these questions a couple of minutes or so, and after that we'll move directly to the Q&A period. So do be sure to stay on the line and or in the meeting room to participate. We have finished a little bit early, so if we have quite a few questions, then that will be great because we will have the time. All right, so let's give these a couple minutes and then we'll move directly to the question and answer period. Thank you. Okay, everybody, we're going to give this just about 30 more seconds and we'll move along to the question and answer period. Okay, let's go ahead and move along to the question and answer period. I see what I'll need to do is actually upload the presentation file for you to download. So just a few words about what you see here. So this particular presentation has been recorded. It will be posted not only to our online Adobe Connect catalog, as I mentioned earlier. You see the information at the tinyurl.com Earthdata webinar at the bottom of the page. There is also, you can find archived webinars from not only this year, but 2014 and 2013. So there are a number of data access and discovery webinars that are housed there. In addition, it will also be posted to the NASA Earthdata YouTube channel. Generally, that takes me a couple of days past completion for post-production, and then you should see that by Monday, if not by close of business tomorrow. Okay, and so we did have a question earlier, and so I'm going to go ahead and move to the questions here. The first question, Matt and Brian, is GXML available for SOMI NPP HDF5 data?
So not currently. Like I said, our first XML files you will find available are focused on products here at the ASDC. We have begun coordinating with the NSIDC and Goddard to identify some of their issues, but that specific data set we have not worked with yet. But would be interested if you're leveraging it and you're seeing issues, so we'd be happy to talk with you in more detail and see how we can make sure that our framework will support it.
Okay, thank you. So the next question is, will it be possible to update these HDF files to avoid issues like missing no data upside down or disordered dimensions?
Yeah, this is Matt. As well as the GE effort, we're also working directly with the science teams to let them know that some of these issues that we're seeing within these applications, so that hopefully in the future with stronger standards and more adherence to these standards, that we won't have to actually have these fixes in place and the data files will work natively directly in these applications without any fixes being applied.
Okay, thank you. Any additional questions? There must be another question. All right. Well, thank you, Chris. And thanks to Matt and Brian. Are there any further questions? This might be a first. Okay, well, if there are no further questions, what I will do is leave the meeting room opened for an additional 10 minutes or so, and I can see here that I need to actually upload the final presentation from our speakers. And so this would give you an opportunity, for example, to download the presentation files. So you'd have the PowerPoint while you're waiting on the recording. And so to download the files, you would simply highlight by left-clicking, and you should be prompted with an option to download that file. We do have another question. Do you have a plan to expand the G to cover NetCDF files?
Yeah, actually, although we refer to HDF throughout, it does support NetCDF in most instances as well. But we do continue to look at some of the NetCDF products that we make available and similar challenges.
Okay, great. Thank you. Any further questions? Well, I'd like to thank all of you for joining us today. If there are no further questions, again, I'll leave the virtual meeting space open for the next 10 minutes or so, and we will log off from the telecon. So I'd like to thank all of you and also thank our speakers, Brian and Matthew Tisdale, for the talk today. All right, well, thanks, everybody. Bye-bye now.